Hello everyone, welcome to free crash course for competitive exams held by VIRAT Hindustan Sangham in association with Manifest IAS Bengaluru. This program is inspired by Dr. SWAMY and is convened by Ravishankar sir, State Education Convener for VHS Karnataka branch. I am the chief mentor of your program, mentoring competitive exam aspirants for past 5 years. So today we will be finishing the India Physical Geography and moving towards India Human Geography. So you can watch this program online on the YouTube channel of VIRAT Hindustan Sangham, and also for further any queries, guidance and doubt clearing, you can join our Telegram channel VHS Education Forum. Right? Okay. So yesterday we spoke about the biosphere reserves. So there are totally 18 biosphere reserves in India, out of which 12 are named under the UNESCO Man and Biosphere program. So these 12 are very important from your exam perspective. You should remember the names. So I'll show you the maps as well. So you have Gulf of Mannar Biosphere Reserve. Gulf of Mannar Biosphere Reserve is here near in Tamil Nadu, and Agastya Malai. Agastya Malai is in the border of Kerala and Tamil Nadu, right? So, and you have Nilgiri. Nilgiri in the tri-junction of Karnataka, Tamil Nadu and Kerala. Nilgiri Biosphere Reserve. Then you have Pachmari Reserve in Madhya Pradesh. Ashnamakar, Amarkantak also in Madhya Pradesh. Similipal in Odisha. Sundarbans in West Bengal. Then you have Nanda Devi in Uttarakhand. Then Kanchenjunga in Sikkim, as well as Nokrek, Manas, you will find it in Assam. Nokrek you will find in Meghalaya, Manas you will find in Assam. Then Dibru Saikova in Arunachal Pradesh. So Dibru Saikova is in Assam, whereas Dihang Dibang is in Arunachal Pradesh. So this is the map of the biosphere reserves. You should know the biosphere reserves in and out, all the 12 of them which are named under the UNESCO Man and Biosphere program, right? So today we will talk about the type of soils in India. So what are the type of soils? How many type of soils are there? Why is soil important? What are the problems associated with soil? So is there any soil erosion that is taking place? Is there over cultivation? Is there under cultivation? What are the types of chemical fertilizers that are being applied? What is the irrigation that is being done? So all these are the things which comes under the soil, especially the soils in India. So this soil is the most important layer of the earth crust, right? Why soil is most important? Because all your food, the variety of foods you eat, even the clothes you wear come from the soil. So without soil, the earth would have been, we would have starved to death. So for the food, whatever you obtain, it is from the soil. So soil is the most important layer of the earth's crust, right? It's not the minerals, it's the soil which is very, very important. So this soil, it has evolved over thousands of years. So the soil, if you take up a soil, it is not a work of 1 or 2 days. It has evolved over millions of years, right? Since the beginning of earth, there has been lot of geomorphic processes, exogenic processes, endogenic forces, everything has acted upon to form a layer of soil, right? So soil is a very important layer. So how does this soil is formed? I have told you in World Physical Geography, it is by a weathering of rocks. Weathering and also gradation. Gradation is reduction of mountains. So because of weathering and gradation, you have found you will find the formation of soils on the surface of the earth, right? So this soil, what does it compose of? What is the composition of soil? So if you look at the soil, it is majorly rock debris. That is rock in a fragmented form. So small rock particles plus organic particles. That is the leaves of trees, the dead animals, the microorganisms. All these two form the major part of the soil. Soil is composed of these two things. So Next, we will look at what are the factors that contributes to the formation of soil. How is the soil formed? On what factors does the soil is affected? The first is relief of a place. That is, whether you have mountainous terrain, whether you have plain terrain, right? Whether you are on the coastal terrain. So everywhere the soil differs. So relief of a place, I have told you what is a relief. Then parent material. So that is the parent rock from which the soil has formed. Is it a igneous rock? Is it a metamorphic rock? Is it a sedimentary rock? That also impacts the soil. Then climate of a place, whether it is a rainy climate, tropical climate, or a desert climate, polar climate, everything affects the soil. Not only that, vegetation of a place, whether it is a forest, whether it is a forest area, whether it is deciduous area, whether it is polar type of vegetation, or it is agriculture. Every type of vegetation affects the soil. Then time also impacts. So the more the time you give, better the soil will become. So time also has a important factor, but more than all these, so these are abiotic factors, right? So the more than all these, the most important factor is the humans. How humans impact the soil. We put all the fertilizers, pesticides. We will use, more than use, we misuse the soil. So humans are the most important factor for the formation of soil, right? So I've told you the components of the soil, that is, one is rock debris as well as the organic material. Some other components are rock, soils include the mineral particles, minerals, right? Various type of minerals, silica, aluminium, iron. You name the mineral, it is found in the soil, right? That it includes humus, humus is dead vegetation, that is degrading vegetation. Not only that, the soil includes water as well as air. So all these are the components of the soil, right? So if you, so this is about the components of the soil and factors of formation of soil. Next, we will talk about the profile of soil. So soil profile is very, very important. So what is soil profile? Soil includes basically three layers. One is the horizon A, horizon B, and horizon C. So these are the three layers. So horizon A is the topmost layer. The surface, whatever you see, that is the horizon A. So what does it include? It includes organic material, that is the dead leaves, dead animals, all these things. Not only that, it includes the minerals as well as nutrients, water, nutrients, everything you will find in horizon A. Next is horizon B. Horizon B, see, it is a sandwich between horizon A and horizon C. So horizon B includes both the material from here also and material from C also. We will look at what are the material found in the C, horizon C. So it is, horizon B is called as a transition zone. It is transition between horizon A and horizon C. It is a middle layer, right? Next you have the horizon C layer. Horizon C layer, you will find the loose parent material. So to know about loose parent material, you should know what is below horizon C. So below horizon C, you will find the parent rock. So because of this rock only, the soil is getting formed. So this rock fragments, broken into small fragments, loose parent material, you will find in the horizon C, right? That is the horizon C, right? Fourth layer is the parent rock or the bedrock. So this is the soil profile, the entire soil profile we have spoken about, right? Okay. So see, this horizon C is very, very important because it will have an impact on horizon B as well as horizon C, right? So this is the soil profile. So next we have now we have spoken about the soil profile. Next we will look at the classification of soils, how soils are classified in India. So first we will look at how soils were classified in ancient times. So what do you think? Do you think that the agricultural technology or the soil technology, was it better earlier or now? So even our ancient people or our ancestors also know about how to classify the soil. They were better judges of the soil. They used to conserve the soil. Whereas today we are misusing the soil. So in the ancient times, our traditional ancestors, they classified the soil into two layers, right? The first form is Urvara soil. First is Urvara and second is Usara. Urvara. So what is Urvara? Urvara means it is a fertile soil which is good for cultivation. Usara soil. Usara is sterile soil, infertile soil which is not good for cultivation. Urvara and Usara was the classification done by our ancestors. So later on in modern times, post 16th century, we are trying different methods or scientific methods of classifying the soil. How do we classify the soil on the scientific methods? We classify it based on texture. Texture means what? As soon as you look at a material, so how does it look to you? Whether it is having small grains or whether it is having big grains, right? Whether it is powdery form or whether it is crystal form. So as soon as you look at a material, so if you look at this phone, so you can see that it is having solid texture, right? Hard texture. So as soon as you look at this bottle, you will find it having some plastic structure. That is, it is flexible. It is not as hard as a mobile phone. So that is the texture. So based on texture, you will classify the soil, and that is whether it is sandy, whether it is crystal, that kind of soil. Then you classify the soil based on color, red soil, yellow soil, all these, black soil, all these types. Then you classify the soil based on the slope. So on which slope it is formed, whether it is formed on the plain area or it is formed on the slope area. Based on that, you will classify the soil. Then you will, last classification is based on the moisture. How much moisture content is there in the soil, right? These are the types of classification of soil in the modern times, that is post 16th century, based on scientific classification. So when you look at the, so which organization does the classification in India? So I have told you classification is done. Who does it? So is it done by the farmers themselves, or is it the scientists, or is it the government? So there is one organization called Soil Survey of India. This is responsible. This organization is responsible. When was Soil Survey of India was formed? It was formed in 1956. This is very important. And also then there is one more organization under Indian Council of Agricultural Research. So this is a council under Ministry of Agriculture and Farmers Welfare. So under this council, there is one more organization called National Bureau of Soil Science, Soil Survey and Land Use Pattern. That is National Organization, or the National Bureau of Soil Survey and Land Use Pattern. So this also classifies the soil. So with respect to this National Bureau of Soil Survey, what they have done is they have classified the Indian soils based on US Department of Agriculture taxonomy. So US, they classify the soil in a different way. So this National Bureau of Soil Survey, they have taken the same methodology and implemented in India, and based on that they have classified the soil. How they have classified? Based on USDA taxonomy. So this is how they have classified. ICAR, that is National Bureau of Soil Survey, they have classified the Indian soil into inceptisols, entisols, alphisols, vertisols, aridisols, altisols, mollisols and others, right? So this is actually very difficult to remember, but they might ask this question, how it is classified, what are the, so these terms are important. So what I'll suggest is a shortcut is, you just remember the top two layers and top highest two soils with highest 2 content and smallest 1 content. So which is the highest type of highest share of soil? It is inceptisols. Inceptisols is the highest. How much it is there? Approximately 40% of India is having inceptisols. Then you have the next thing is entisols. Entisols is having how much? 28%. Entisols is having 28%. So these two, you remember, it is enough. Don't worry about alphisols, vertisols, all these things. You can know about these aridisols. Aridisols is what? Arid. That is in the desert, you will find the aridisols layer. So you should know about the mollisols. Mollisols, how much it is having? Percentage 0.4. This is the least. Mollisols is the least. in inseptisols and in entisols are the highest. If you remember this much with respect to USDA taxonomy, it is more than sufficient, right? So this is one classification. So we have Indian classification also. We have our own indigenous classification. So on what basis have we classified the soil? Indians, that is Indian organizations, how have they classified? They have classified based on the color of the soil. They have classified based on the composition of the soil. What does the soil compose of? They have classified based on the location of the soil. Not only that, they have classified based on the genesis of the soil. How has the soil originated? So these are the various factors based on which soil is classified in India. So with respect to that, the first important soil in India is your favorite alluvial soil. Where is alluvial soil found? In the Ganga plain. See, whenever they say alluvial soil, just remember it is formed out of rivers. So whatever the river debris, whatever the rocks it is taking from the mountains, it is going to come and throw it in the plains. That is the alluvial soil. I have discussed the various rivers, young stage, youth stage, mature stage, old stage. So in the youth stage, the rivers will carry all the debris material and throw it in the mature stage. That is as soon as it finds the plain. So the best example is your Ganga plain. So this entire area you are having alluvial soil, very, very important. So this is found in the northern plains, that is in the Ganga plains. So how much percentage of area is alluvial soil? Very, very important. 40% of India is covered with alluvial soil, the highest form. That is why, see, you find the Ganga plain, it is highly cultivated. Huge population, UP, Bihar, Punjab, Haryana. Why? Because of alluvial soil. So they do multiple crops, 3 crops per year, right? Because of alluvial soil. So it is 40% of area, 40% of India's area. Then it is a depositional soil. I have told you what is a depositional soil. It is deposited by the rivers. Then where do you find this soil? Not only there. So you will find this soil here also. See, in the deltas. See, this is what delta? This is Mahanadi delta, right? And this is Krishna Godavari delta, Kaveri delta, all the delta, wherever the river merges with the oceans, there also you will find this type of soil, right? So alluvial soil. Then what is the texture? Texture of this soil. So it is from sandy. It looks like a sand. It looks like, sometimes it looks like a sand, sometimes it looks like a clay. So first I'll show you what is a sandy, loamy and clay soil, because without knowing the texture, it is very, very difficult to have a grasp of the concepts. How does a sandy soil look? How does a loamy soil look? How does a clay soil look? So before that, we'll discuss the content of the soil. This alluvial soil is very, very rich in potash. Potash content. The potash is very, very high. Phosphorus is very, very low in this soil. So this soil is classified into 2 layers. Alluvial soil is classified into 2 layers. One is Kadar and Bangar. What is Kadar? Kadar means new alluvium. So the alluvium deposited by the rivers in the recent times is Kadar. Bangar means old alluvium deposited many years ago. How do you remember this? Bangar means old. So just remember, old is gold. So Bangar means gold, right? Old is gold, you remember? Bangar is a old soil. Kadar means new soil. This is a shortcut I am giving you, right? So not only that, this alluvial soil is having calcium concentration, calcareous concentration. Some parts it is having high concentration of calcium. This is called as Kankar concentration. Wherever calcium is high in the alluvium, it is Kankar concentration. What is the color of the soil? What is the color of the soil? It varies from light grey to ash grey. So majorly it is grey color. Alluvium soil is grey color. So it is used for these, wherever alluvial soil you will find, it is having high concentration. So I'll show you the texture of the soil. One second. Loamy soil. Because we have been studying loamy, clayey, sandy since our school days, but till now we have Not understood. How does it look like? Okay, let it load. So the next type of soil we are talking about is the black soil. Very, very important. Where do you find this black soil? So black soil, see this entire area is black soil. The northern part of Karnataka, Maharashtra up to the some parts of Gujarat and Madhya Pradesh, you will find the black soil. This is entirely in the Deccan Plateau. See, this area is Deccan Plateau, right? You will find the black soil in the Deccan Plateau, Maharashtra, Madhya Pradesh, Gujarat and Andhra Pradesh. So this soil is also called as black cotton soil. Why it is called black cotton soil? You will find the cultivation of cotton in this area. A lot of cultivation of cotton in this area. This soil is also called as rigor soil. Very, very important. They will ask you what is rigor soil. You should know it is black cotton soil, right? Then this soil, the texture, if you look at the texture of this soil, it is clayey. So see, this is the loamy soil. See, this is how the loamy soil looks like. What happened with the internet? It is slow. Can you look it from here? ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? Okay. See, this is how the loamy soil looks like. See, loamy soil andre, you just remember it is a mixture of clayey, sandy, all type of soils. So it looks like this. Loamy soil looks like this. Loamy soil looks like this. Did you see this? Okay, see, here they have given loamy soil is the mixture of clay, sand and silt soil. All the soils mixed together is the loamy soil. Then we will look at clayey soil. How does clayey soil look like? Clayey soil. Clayey soil ಅಂದ್ರೆ ಏನಪ್ಪ ನಿಮ್ಮ ಕೆರೆ ಮಣ್ಣು ಅಷ್ಟೇನೆ. ಅದೇ clayey soil. This is clayey soil. Understood? This is how the clayey soil looks like. Then you have the sandy soil. Sandy soil is just like what do you find in the deserts. So this is how the sandy soil looks like. Sandy soil having the texture of sand. From the river beds you will extract this. So then you will have silt soil. So this also looks like this. Silt andre, it is the accumulation of the soil. Silt means what? In Kannada it is called as kasa. So silty soil, you find it in the river beds at the bottom of rivers, right? Silt. So it is similar to clayey soil, right? So this is the various textures of the soil. How does the various soils look like? Okay. So we were talking about the black soil. Black soil is having a clayey texture, right? Clayey texture. It is having goes up to very deep level and it is impermeable. Impermeable means what? The water, if there is black soil, the water won't sink into it. It will remain within the soil. It won't leave the soil to go to underground, right? So this soil has a very special character. This soil, black soil, what? See, whenever this soil gets wet, it becomes sticky. Antkollutte, sticky. Whereas whenever it becomes dry, it shrinks. It will sticky shrink. See, the best example is ನಿಮ್ಮೂರ್ ಕಡೆ ಕೆರೆ ಇರುತ್ತೆ, ಕೆರೆ ಒಣಗ್ದಾಗ ಏನಾಗುತ್ತೆ, ಅದ್ರ ಒಳಗಡೆ ಕ್ರ್ಯಾಕ್ ಬರಲ್ವಾ? ದಟ್ ಈಸ್ ಶ್ರಿಂಕಿಂಗ್. ದಟ್ ಈಸ್ ಬ್ಲಾಕ್ ಸಾಯಿಲ್ ಶ್ರಿಂಕಿಂಗ್. ಬಟ್ ಅದೇ ನೀರ್ ಬಿದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಕೆಸರಾಗಿ ಹೋಗುತ್ತೆ ಫುಲ್. ಇಟ್ ಬಿಕಮ್ ಸ್ಟಿಕ್ಕಿ, ರೈಟ್? ದಟ್ ಈಸ್ ಬ್ಲಾಕ್ ಸಾಯಿಲ್. This has a very special character. Because of this soil, this quality, this soil is called as self-flowing. Flowing means what? ಉಳೋದು, ನೆಲ ಒಳ ಉಳೋದು. So see, it contracts, shrinks and it expands. Because of this soil, what happens? It is self-plowing. Andre idine ulume madadu, but automatically if you throw the seed, it will grow up. So it is called this soil. Which soil is called as self-plowing? It is the black cotton soil. So this soil is very useful for cotton cultivation. Why? Because it retains the moisture for long time. ಒದ್ದೆ ಅಂಶ ತೇವಾಂಶ ತುಂಬಾ ದಿನ ಇರುತ್ತೆ, right? So even in dry season there will be wetness in the soil, right? So what is the color of this soil? It varies from black to gray. From black color to gray color it varies, right? So what are the chemical composition? It lacks phosphorus and nitrogen, and also it lacks organic matter. There is no organic matter, there is no phosphorus, there is no nitrogen in this soil, right? So what does it contain? It contains lime, potash, all those things. I don't think they will ask that in the exam, right? What is the chemical composition? Next is the red and yellow soil. Red and yellow soil, yeah, the name itself suggests it looks yellow in color and it also looks red in color, right? What is this red and yellow soil formed of? It is formed of the igneous rock. From the volcanoes, whatever the rocks are formed, from the igneous rock, this soil is formed. So where do you find this? Where do you find this? What soil? Red and yellow soil. You will find it. See here, East Deccan Plateau and South Deccan Plateau. South of Deccan Plateau and East Deccan Plateau, you will find the what soil? Red and yellow soil, right? So this also you will find in the Piedmont here. Piedmont means what? Piedmont means, see, if there is a mountain, here is the plain. So this junction of mountain and plain meeting is the Piedmont. So there also you will find the mountain, that is Western Ghats meeting the plain. There also you will find the red and yellow soil. So this soil is you can see this soil wherever there is low rainfall. Red and yellow soil, low rainfall. Why it looks red in color? Because of the iron. If there is iron in the soil, then only it will look red in color. When does it look yellow? When the iron gets hydrated. When iron gets oxidized, it will look yellow, or it is mixed with water, it will look yellow in color, right? So this is about the red and yellow color. So this lacks nitrogen, phosphorus and humus. This also lacks nitrogen, phosphorus and humus content, right? So this is about the red and yellow soil. Next we will talk about the laterite soil. Laterite soil is a very special type of soil. See, if you have to understand the laterite soil, first you should know the term laterite. So later means brick. So ಇಟ್ಟಿಗೆನ ಯಾವ್ಯಾವ ಮಣ್ಣಿಂದ ಮಾಡ್ತಾರೆ? ದಟ್ ಈಸ್ ಲ್ಯಾಟರೈಟ್ ಸಾಯಿಲ್, ರೈಟ್? ಇಟ್ಟಿಗೆ ಮಾಡೋ ಸಾಯಿಲ್. ಸೊ ಲ್ಯಾಟರೈಟ್ ಸಾಯಿಲ್. So that is why it is used in house construction, making of bricks. So where do you find this soil? You will find in those areas where there is high rainfall and high temperature. Red and yellow soil, low rainfall. Laterite soil, high rainfall, high temperature. So this soil, because of high rainfall, what happens? Whatever the chemical content is in the soil, that is removed. So the chemical is removed from the soil. So there is after all the chemicals is removed, only two things are left out. So what is left out? That is lime and silica is left out. Every other mineral is taken out of the soil, leached out, right? So this soil is poor in organic content, it is poor in nitrogen, it is poor in calcium. Alluvial soil is rich in calcium. That is why it is called Kankar nodules. Whereas this soil, laterite soil, is poor in calcium. So what is it rich in? It contains lot of potash and iron oxide. The chemical content, I don't think they will ask, right? So this laterite soil is not good for cultivation. You cannot cultivate it because there are no minerals. It is low in fertility. But if you put some fertilizers, if you put some manure, you can cultivate. So your cashew nut. So the cashew nut is Godambi, is grown in laterite soil, right? So the next we will talk about the, so where do you find the laterite soil? So laterite is very low. You will find it here, you will find it here, here. So somewhere here, right? Here. Okay. Next we will talk about the arid soil. Arid soil, where do you find the arid soil? Wherever desert is there, there you will find the arid soil. What is the color of the soil? It varies from red to brown color. Red to brown color. What is the texture of the soil? It is sandy, lot of sand. and it is saline. Saline means uppinamsha irutte. If you dry this soil and evaporate, you can actually manufacture salt from the soil. So it is saline. Common salt can be obtained out of it, right? So this soil does not have any moisture. Because it is dry, you don't find any moisture. It is very, very dry. And it is not having the humus content also. There is no humus content as well. So just like alluvial soil, even in this soil, at the lower layer of the soil, you will find kankar nodules. Kankar means calcium. Calcareous deposits is called as kankar nodules at the lower levels. So wherever calcium deposit is there, there is low permeability. The permeability will be very low. Permeability low, and what do you mean by permeability? Low permeability. So see, if this is a layer of soil which is having low permeability, if you put water, it won't come here. It will get stuck here. That is what is meant by low permeability, right? Where do you find this arid soil? See, it is found in the western Rajasthan region. That is where you will find this soil. Next, we will talk about the what type of soil. So you are left with the saline soil. Saline. So saline, the name itself suggests it is rich in salt, right? So it is also called as a usara soil. What is usara soil? Infertile soil, sterile soil, right? So it is high in sodium, potassium and magnesium. Salt content is very, very high. So it is infertile. It is not good for vegetation. You cannot grow anything in the saline soil. Where do you find it? It is found in the dry climate. That is arid regions. Same arid soil. Those regions only you will find it. Not only in the arid region, saline soil, one speciality is you will find it in the waterlogged region as well. Waterlogged means some areas which is always filled with water, like lakes. There also you will find the saline soil, right? What is the texture of this soil? Texture of this soil, it is sandy to loamy texture. I have told you what is sandy, what is loamy. Where do you find this soil? You will find it in western Gujarat. Western Gujarat, somewhere here, you will find the saline soil, and also Sundarbans. Sundarbans also you will find the saline soil. Because Sundarbans is what? It is waterlogged, right? Every time it is, you will find water in the region. Mangrove cultivation, that is why you will find lot of saline soil there, right? So the one special thing you should know about the saline soil is, it is found in the green revolution areas. What are the green revolution areas? Punjab, Haryana, Western Uttar Pradesh, where they did the green revolution. So why green revolution areas? Because see, saline soil, I told you, it is found wherever there is water logging. Whenever there is water logging, what happens? So when the water is removed, so there will be this action called as capillary action. What is capillary action? So this salt content, that is magnesium, sodium and potassium, it will be below the earth. It will be deeper inside the earth. So when the soil is filled with water, what happens? There is one action called capillary action. It is better for me to show you with a diagram. Let's say this is a soil, it is flooded. So alluvial soil. So alluvial soil itself becomes saline soil. How? Let's say this is a layer of soil, it is flooded with water. What happens? Because it is flooded with water, small capillaries develop. What is capillary? Small tubes in the soil develop. Because of this capillary, what happens? The salts here, magnesium, sodium and potassium, they go up and get accumulated here at the surface, right? So why do they go up? Because of the pressure difference, right? So the best example is, see, if you want to take petrol or water from a tank, what do? You put a pipe, you will suck it and leave it. So the water will be continuously flowing, right? You need not keep sucking it. That is capillary action. So once the pressure is removed, the water will be flowing continuously. That is how they use the, that is how they try to extract petrol from the vehicles. So petrol thieves, they suck the petrol and put it in the bottle and take all the petrol, right? So petrol thieves use this technology. Similarly is the capillary action, right? The salts get accumulated at the surface level. Surface level, salts get accumulated. So, in order to reduce the salinity, what should be done? So, saline soil can be made fertile by adding gypsum. Gypsum should be added to the saline soil. So, the next type of soil is the peaty soil. So, peatland topography, you should know what is peatland topography. Peatland is something really similar to marshes and swamps. So, I will show you what is a peatland. So, this is a peatland. So, it includes both water and this type of grasses. Can you see the peatland? Please look at it, because or else you will be confused, right? So this is a peatland. Clear? This is how a peatland looks like. Where was the image? Okay. So this is how a peatland looks like. So in these areas you will find the peaty soil. So it is in those areas where there is high rainfall and high humidity. Where there is high rainfall is high and humidity is higher. Humidity means moisture content is higher. So this soil is good for growing vegetation. It can be used for growing crops, right? So the organic content in this soil is very, very high. Organic content means the dead organic matter. Dead organic matter will be very high, because of which the organic content, organic capacity of this soil, andre new manure hakade bada. Without that it will grow. So what is the color of the soil? It is black color. It is having black color. Where do you find this peaty soil? You will find it in the northern Bihar and eastern coast. Somewhere here and northern Bihar part you will find the peaty soil. So this is about the peaty soil. Then you will talk about the forest soil. See, this is where you will find the forest soil. So, right? Where is the forest? What is forest soil? Where there is good rainfall. See, forest soil means those soils where you will found in the forests. Right? Where there is good rainfall. What is the texture of the soil? It is from loamy. It varies from loamy to silty. Loamy to silty. Right? So this soil is fertile in the valleys. See, the speciality about forest soil is, let's say this is a mountain and this is a valley. So whatever the soil you will find in the valley, it is fertile. Whatever the forest soil you will find on the mountains, it is not fertile, it is infertile, right? So this is the speciality of forest soil. So at the valleys it is loamy and silty. At the upper slope it is coarse, that is crystal form. Crystal form you will find in the upper slope, right? So this is about the forest soil. If you know this much, it is very, very sufficient. So we have spoken about the various type of soils till now. So why is soil important? See, as you see all these soils, don't you think soil is also a living being? Because it gives life. It gives life for the crops. It gives life for the animals, right? So this soil is also, they also get born, they are also dying. So they also develop, they also decay. So, but one thing that is happening bad for the soil is soil degradation. Degradation of the soil because of excessive chemical fertilizers, excessive pesticides, excessive cultivation. Soil ge rest illa. One crop admele innond crop haagtane irtare. So and also you put some hazardous materials, right? Hazardous, poisonous material on the soil. So pollution, plastic and all get accumulated, and also you will encroach the soil. Soil idre, you will build buildings over that, because of which soil is lost. So these are all the degradation of the soil. So soil degradation means, it just simply means decline in fertility. Soil is not good for cultivation. If the nutrition decreases, that is when the soil gets degraded. So now we will speak about one very important concept called as soil erosion. Okay, soil erosion. So what is soil erosion? Loss of soil is called as soil erosion, as simple as that, right? Who erodes the soil? It is either water or wind. Water removes the soil or wind removes the soil. Water, so with respect to erosion of soil from the water, you will find sheet erosion and gully erosion. What do you mean by sheet erosion? Sheet means thin layer of the soil gets eroded. So the upper layer of the soil, if it gets eroded, it is called as sheet erosion. The top sheet of the soil gets eroded. Why does it get eroded? Because of the water. So you will find the sheet erosion in the level lands, plain lands. The top soil gets eroded. Then is gully erosion. Gully erosion you will find in the steep slopes, not on the plain land. On the slopes you will find the gully erosion. So whenever gully erosion happens, you cannot grow any crops there. I will show you what does a gully looks like. You cannot grow any crops, no cultivation. So because of gully erosion, there is one type of topography called ravines. Development of ravines, bad land topography. Where do you find ravines? I have told you, you will find it in the Chambal region, Chambal ravines. I have told you Chambal, how does it look like, right? So as per the Government of India data, we have every year we are losing 8,000 hectares of land to ravines every year. 8,000, so that's a very big number. How does a gully look like? Gully erosion, not the gully of the, what do you talk about, or not the gully of the cricket. So this is gully erosion. Gully erosion. So see, this is how the gully erosion looks like. So can you grow any crop here? No, impossible. It's impossible to step our foot on it. We will fall. Right? So this is how gully erosion looks like. Okay. Okay, so next is, this is with respect to erosion from the water. Next we will talk about the erosion from the wind. Wind erosion you will find in the desert region, that is arid. So this is how a gully erosion looks like. So wind erosion you will find in the arid and semi-arid areas where there is desert, right? So with respect to the talking of natural erosion, see, erosion is a natural process, but there is as much as the erosion, that much there should be deposition. Then only there will be a balance. But what happens, sadly, humans have disturbed it. Humans have disturbed the natural erosion, and there is artificial erosion now, right? What is the impact of the erosion? What impact does it have? See, because of soil erosion, what happens? It causes floods. See, what happens, this soil, they will go and get accumulated in the river. So river level will rise, right? So river will spread in the normal area. So river, the channel of the river, if it is filled with the soil, where will the river go? So it has to flood, right? It has to flood the villages. So flooding will happen. Not only that, it will damage the agricultural lands, right? So what is the cause? One of the causes of the why does the erosion takes place? It takes place. One of the causes of erosion is deforestation. See, what happens if there are trees, they will hold the soil together. The roots, so you have seen the roots of the coconut tree, right? Coconut palm. So it is actually very huge. So it holds the soil together. But if you remove the tree, what happens? The soil will loosen up and the soil will flow, right? It will get eroded, right? Deforestation is one cause. Then the next cause is over irrigation. If you fill the soil with too much water, over irrigation is also one cause. And because of over irrigation, salinity increases, capillary action, all that I have told. Not only that, chemical fertilizers, adding chemical fertilizers is also one of the cause of the soil erosion, right? So this is about soil erosion. They have told that half of the land, half of India's land is degrading because of soil erosion. As per the Government of India data, half of India's soil is degrading because of soil erosion. So soil erosion is there. Whenever soil erosion is there, we should talk about soil conservation. How do we conserve the soil? So soil conservation means improving the condition of the soil, making the soil fertile, right? making it fertile, making it good for cultivation, making it not to flow or making it not to erode, right? So there are various techniques. So what is first technique is, first is checking the erosion on the slopes. So checking erosion of slopes. How do you check the erosion on slopes? If you see what happens if you do cultivation on the slopes. So tea cultivation, all those things. It is if you do without if the gradation is like this. If the slope is like this, if you just plant the trees, it is not going to help. It will actually increase the erosion. So how do you decrease the erosion on the slope? You will form terrace farming. I will show you how a terrace farming looks like, right? You should form terraces, counters, or counter plowing, all those things. I will show you how does a terrace farming looks like. Terrace cultivation. Okay, let it load. So terrace cultivation is one method of reducing the soil erosion. Then is we should reduce overgrazing. If you do grazing, what happens? The grasses are removed and soil will get eroded. That is also one that should be reduced. Shifting cultivation, jumming has to be reduced. Jumming, what is jumming? Slash and burn cultivation. So these tribals, no matter what they do, they will clear a forest, do some agriculture, later on move to some other place. That will also lead to soil erosion. That should be stopped. Then counter bonding and terracing. Why is the internet slow? See, this is terrace farming. Like this. These are called the terraces. You cannot do plain cultivation. You should do terrace type of cultivation. This is terrace farming. Then counter bunding. So this also looks similar to terrace cultivation. This is counter bunding. Right? So if you do like this, soil erosion will reduce. This is counter bunding, soil erosion will reduce, right? So terracing, what does it do? Terracing will remove the gullies. Gully will be there, no? That will be removed. And if the gullies are big gullies, just like Chambal, what should we do? We should build dams. Check dams should be built so that soil doesn't get eroded. Then headward erosion. See, what the problem with these gullies is, if there is a gully like this, if it is like this, what happens? So let's say if this is a block of soil, here gullies are formed. So gullies undergo headward erosion, that is headward, that is towards the, so if the gully is getting expanded here, towards the head also it is getting expanded. So what we should do? We should plug the gully, we should put something, we should put some crop, we should put some rock there, so that gully is plugged, right? So that is one thing. Then we can also implement mixed farming. Mixed farming is growing multiple types of crops. That can be done. Then crop rotation can be done. That is various type of crops if you grow, it will help in soil conservation. So we should also prevent desertification, that is soil getting converted into desert. So how do you prevent? So see, in the desert, what happens? This sand dunes are there, right? Sand. In the desert, you will find sand. So those sand dunes, slowly they will encroach upon the surrounding area. So here, if there is a sand dune like this, if this is a desert area, if this is a fertile area, slowly this will encroach this area also. So what we should do? We should put tree shelter belts. Here we should put tree shelter belts, so that the sand desert doesn't get extended, right? We should put a barrier, right? So what are the institutions which are helping in the soil conservation? There is one organization called Central Arid Zone Research Institute. So this is helping with the prevention of desertification, that is normal soil getting converted into the desert. This institute is helping. Then they say that which is the best method of conserving the soil conservation. They say integrated land use planning. What do you mean by integrated land use planning? So if there is a area, so some area crop should be grown, some area tree should be grown, some area it should be left fallow, so that it bird bitre enagutte, it will rejuvenate, rest kodbeku soil ge. Some area that should be there, some area should be used for growing grass. So if you do like this, integrated farming, soil conservation happen. That is the best method, right? Okay, so this is about the soil. Next we will move to the chapter on natural hazards and disasters. Natural hazards and disasters. So when we talk about the natural hazards as well as disasters, first we should know the difference between hazard and disaster. See, hazard is a danger waiting to happen. So if there is so we are talking about natural hazard. So let's say there is a lake. So lake is getting filled with lot of water due to rain. So what happens? There is a threat of flooding, but flooding has not happened. So that is a hazard waiting to happen. So it is a small scale. So on the small scale it will happen. But disaster happens on a large scale. Always disasters happen on a large scale. Disaster is very destructive. That is the difference between hazard as well as disaster. Disaster waiting to happen is a hazard. Disaster is actual occurrence. Natural hazard happens on a small scale. Disaster happens on a large scale. So this is the difference. So when it comes to hazard and disaster, do we humans have any control over them? No, humans do not have any control over them. And do we desire the disasters? No, we don't desire the disasters. We don't want any disasters. But even then, disasters keep happening. They cause us lot of damage. Damage to our ecosystem, damage to life, damage to property, damage to soil, damage to buildings, damage to infrastructure, right? Damage to agriculture. Everything happens because of the disaster. So what are the types of disasters? You have floods, we have droughts, we have earthquakes, we have volcanoes, we have tsunami, right? So cyclones, all these are the disasters. So see, when we look at the disasters from nature's perspective, see, let us say we are the nature. So if there is a disaster, actually for the nature it is not a disaster, it is a normal occurrence. But for humans, if you think from humans' perspective, it is branded as a disaster. For nature, see, if some person dies or some animal dies, does it matter to the nature? For nature, it is normal occurrence. But for humans, it is something big, some close relative has died. So that kind of change, actually from the nature perspective, it is not having any value. But for humans, we don't desire that type of changes, right? So these disasters can be local, they can be at the smaller scale or at a bigger scale. Tsunami at a bigger scale, local, smaller scale, landslide or so other things. So during earlier times, ancient times, they thought that disasters are happening because of natural forces. Because of nature, disasters are happening and humans do not have any control. We are just at the control of nature's fury. We don't have any control, we just have to suffer. But with the invent of science and technology, now we have come to understand the disasters better. We are trying to control the disasters, or trying to mitigate the disasters, or reduce the impact of disasters with the help of science and technology, research, understanding and knowledge, right? So not are all the disasters natural? No, right? Some disasters are human made also. If you take the Bhopal gas tragedy, right? If you take the Chernobyl nuclear disaster, so these are human made disasters, right? Fukushima Daiichi disaster, nuclear disaster. So all these are the human made disasters. Even the landslides, some landslides also are human made, right? So we cannot prevent the disaster. So disasters are natural. Because they are natural, we cannot prevent them, but we can reduce the impact, that is mitigate the disaster, and we can manage the disaster. So with respect to disaster management, there was one conference which took place with respect at the global level in order to reduce the impact of the disasters. So this conference is called a Yokohama Conference. Yokohama Conference, this happens in 1994, very, very important. So this conference is called as World Conference on Disaster Management. It is a World Conference on Disaster Management, happens in 1994, Japan, Yokohama. Why is it important, Andre? There is a Yokohama framework, Yokohama safety strategy. That is why it is important. So earlier, if you look at the disasters, see, early humans, they know about how to, even if you look at the tribals today, they know how to coexist with the nature. That is, they don't create too much disturbance in the nature. So they exist with the nature. Even that was the same thing happening during earlier times also, during ancient humans. Our ancestors knew how to deal with the nature. But the sad reality of today is, because of the need of the resources, because of population explosion, because of our greed, because of the misconceived notion of development, what we are doing is, we are actually meddling with the nature. We are creating disturbance in the nature. That is why, so what happens, see, the best example is, there is a floodplain. Floodplain means what? Let's say this is a river. So this area is a floodplain where flood happens. The flood will come till here. The river water will come till here. So what humans do? The property prices are high. They will go and construct homes here, house here. So when the flood happens, they will cry. So it is humans who are responsible, right? So humans are actually responsible for these type of disasters. So what are the classification of the natural disasters? We will look at the classification. So first is atmospheric disasters. Disaster happening because of the atmosphere. So blizzards, thunderstorms, lightning. You know what is lightning? Tornadoes. Tornadoes are small form of cyclones, right? Reduce or a miniature version of cyclones. Then cyclones, drought, hailstorm, frost, heat wave, or Lu. Lu is a hot wind, I told you yesterday. Cold wave. These are atmospheric disasters. Terrestrial disasters, you have earthquake, volcanoes, landslide, avalanches, subsidence of the land going below, soil erosion. These are terrestrial disasters. Then you have aquatic disasters happening in the water area, floods, waves, tidal waves, tsunami, ocean currents, excess ocean current, storm surge, that is the waves rising, storms happening in the coastal plains. So storm surge, all these are the aquatic disasters. Biological disasters. plants, locust is so what is a locust attack? So we face this locust attack every year. It originates from Iran, Pakistan, and comes to here. Locusts are insects. So they are like lakhs of insects come together to India, and they destroy all the crops. So this they destroy in Rajasthan, Madhya Pradesh. So it is shown in the movie, but I don't think you have watched the movie. So I'll show you how does a locust attack look like. So lot of lakhs of insects, they come and eat the crops. See, these are the insects. See, this guy is fighting with the insect. So they come and eat all the crops. Right? This is a locust attack. Insect. This happens in India as well. There is one Surya's movie called Kapan. So in that movie they have shown about the locust attack, right? Okay. So locust attack, insect infestation, fungal, bacteria, viral diseases, bird flu, dengue, all these are the what disaster? Biological disaster. So these are the types of disaster. So next we will look at the Yokohama strategy. I told you Yokohama World Conference of Disaster Management. So there is a plan of action, Yokohama strategy and plan of action for a safer world. So it includes 4 points. What are the 4 points of the Yokohama strategy? They say that, so if there is a disaster in a country, it is the responsibility of the country itself to take care. The government of the country should take care of their citizens or protect the citizens from the disaster. And the second criteria is they should the country international arena, we should pay attention to the least developed countries, developing countries and small island countries. Why these countries? Because these countries do not have the capacity to cope up with the disaster. That is why they need help. Least developed country, developing country and small island country. Then the third step they say is there should be capacity building. Capacity building means what? So if there is a disaster, we should build scientific capacity to predict the disaster. There should be national disaster response force. Some dedicated force should be there to tackle the disaster. Then there should be a national disaster management authority. Then there should be a national disaster management fund. All these things we have in India. So that is capacity building should be there. Then there should be a legislation. So we have National Disaster Management Act. Disaster Management Act 2005. So that kind of act should be there. Then the fourth step they say is we should collaborate on the sub-regional, regional and international level. At 3 levels, sub-regional, that is at the state level, national level and international level, we should cooperate. Why should we cooperate? In order to build our capacities to tackle the disaster, in order to exchange the technology to tackle the disaster and also to mobilize the resources to tackle the disaster. That is mobilization of funds, mobilization of material, men, all these things, right? So this Yokohama strategy says that this disaster affect the poor people a lot. So we should help them, right? Not only that, not only poor people, it affects the developing countries more. So we should help the developing countries, right? So after this Yokohama strategy, they have named the year from 1990 to 2000. 10 years starting from 1990 until 2000. They have named the year as International Decade for Natural Disaster Reduction. International Decade for Natural Disaster Reduction. Which year to which year? 1990 to 2000, right? Very, very important. So this is about the Yokohama strategy. Next, we will talk about the disasters and hazards in India with respect to India. So when we talk about India, it is a very big country, lot of diversity is there. So it is a very having vast topography. That is why India is called as what? India is called as the Indian subcontinent. It's a very vast country. There are multiple religions, multiple topography, multiple climate, right? Multiple relief. So it's a vast country, and it is vulnerable to natural disasters. We have multiple types of natural disasters. So the first type of disaster we will talk about is the earthquake. Okay. So earthquake. So we have spoken about the earthquake earlier. So this earthquake, when we speak about earthquake, it is, can we predict the earthquake? Can we predict when does the earthquake happens? No, earthquake can never be predicted. It is unpredictable and it causes lot of destruction. So what are the causes of earthquake? So there are two causes of earthquake. So the first major cause is tectonic cause. That is tectonic plate moving. We all know that Indian plate is moving northwards and clashing with the Eurasian plate, right? So because of which, see, when two plates are fighting with each other or there is friction, energy gets accumulated because of the friction. So some point there will be some movement jerk and that energy will be released. So that energy, how does it release? It releases in the form of earthquake. So this Indian plate is moving towards the Eurasian plate. There is lot of friction. So energy is getting accumulated. Suddenly there will be some jerk. Suddenly there will be earthquake. Energy gets released, right? So these tectonic earthquakes, that is the first type of earthquake. So they are very destructive. So Nepal earthquake 2014 or 15. So there is more than 10,000 people died. Thankfully, India was the first responder. So these tectonic earthquake, they affect the largest possible area, right? Very big area they will affect. So the next type of earthquake, so next cause of earthquake is the volcanic eruption. So tectonic forms the one group. The next group is, it may be either because of volcanoes or if there is a big rock which is falling, then also earthquake will happen. And also landslides also causes earthquake. Not only that, even mining areas, dams, everything causes earthquake. All these things we have discussed in the world physical geography, right? Next, okay. So, what are the areas that are impacted by earthquake? So, earthquake impact area. So, 1 second. Yeah. So earthquake impact area, see, is this map visible for all of you? So this area, so we have divided the earthquake impact into areas and zones. So we have 5 zones of earthquake impact, right? So the northeast, the entire northeast area falls under very high damage risk zone. Because of earthquake, there is lot of damage, right? So this is very high damage, the entire northeast India. Next we have the high damage risk zone. So what is high damage risk zone? See, this is the high damage risk zone. That is the foothills of Himalayas. Wherever Himalayas is there, it is a high damage risk zone. See, and very high damage is even the this run of Kutch, Gujarat. That is also high damage, right? Sorry, very high damage. Then moderate damage risk zone. What is the moderate damage? It is some part of Ganga plain, some part of Gujarat, Rajasthan, Western Ghats, and so the entire Western Ghats and some part of Krishna Godavari Delta is also moderate damage to the earthquake. Then you have low damage risk zone. Where do you find the low damage? So the Delhi Ridge, the Rajasthan belt, some part of UP, Madhya Pradesh, your entire Tamil Nadu, some part of Karnataka, Andhra Pradesh. This is low damage risk zone. Then very low damage risk zone, the entire Karnataka plateau, Odisha region, the Madhya Pradesh, Rajasthan region is the very low damage. Thankfully, Karnataka is low damage risk zone, right? From the, okay. So these are the 5 zones of earthquake in India. So, what are the institutions? So, which institutions deal with earthquake in India? So, it is Geological Survey of India and one more institution, National Institution of Disaster Management, National Institute of Disaster Management. They deal with the earthquake. So next we will, so this is the map of earthquake hazard zones. This is prepared by the Government of India, some Geological Survey of India, they might have prepared the map, right? So what are the effects of earthquake? So earthquake in the ಏನೇನಾಗುತ್ತೆ? So on the ground what will happen? Fissures or cracks will develop and landslides will happen. Liquefaction means soil will flow in the form of water. Soil will mix with the water and flow. Earth pressure will be there. It will impact, the other chain effects will happen. So on man-made structure, on buildings, dams, bridges, what will happen? Cracks will happen. There will be some sort of cracks. Some buildings will overturn. They will fall. Some buildings will collapse and chain effects. Then on water, earthquakes, on water, what will happen? Waves. Your tsunami is because of earthquake. Earthquake happening below the water, right? Waves will happen. Then tsunami, all these things are the effects of earthquake, right? Various type of earthquakes on various topography. So what are the consequences of earthquake? Earthquake in the ಏನೇನಾಗ್ತದೆ? See, on people, lot of people will die, right? Lot of animals will die. Lot of property is damaged. So your cars, your buildings, everything you will lose. Some people will become homeless, right? Not only that, this is with respect to people and property. We have impact on the environment as well. On environment, what do we have? We will find Earth's crust. So Earth's crust, the top layer of the earth, there will be cracks developed. So when the cracks will be developed on the earth crust, so water, below water will come out and flood the region. So environmental impact will happen, landslides will happen. So these are the consequences of earthquake. It is similar to the effects. So what should we do to control the earthquake? What is the measure? So we have earthquake hazard mitigation. We cannot stop the earthquake, but we can reduce the impact. So how do we reduce the impact? So we have to prepare for the earthquake. So the first thing is, what are the steps? We have to build some earthquake monitoring centers, scientific and research centers, where scientists work in and out, day and night, to predict the earthquakes or to reduce the impact, right? So seismological centers. So seismology, what is seismology? So there will be some graphs, right? It will be like this. So it will, seismological centers will measure the earthquake, right? Then we have to prepare a vulnerability map. Vulnerability map andre where are the earthquakes are high. So that map, and we have to give that information to the public so that they remain prepared, right? Then we should avoid building houses or big structures on certain areas which is affected by the earthquake. So where there is high risk of earthquake, we should avoid tampering, right? So, and building designs should be modified. So I have heard that in Japan, there is every minute there is one small earthquake. So what they have done is, they are constructing the houses with wood and some earthquake resistant material. So these houses, what they do, even if earthquake happens, it acts like a shock absorber. Just like your bikes have a shock absorber for this humps and all, these houses have shock absorbers in Japan. So that type of design we should build, right? Not only that, we should modify the house types, right? And so these are the things we should have with respect to earthquake. So the first thing is, people should be made aware, and we should avoid tampering with the nature, right? This is all about the earthquake. Next we will move towards the most important thing, the tsunami. Tsunamis, right? Tsunamis are called as, so there are multiple names for tsunamis. Tsunamis are also called as harbor waves, or seismic waves, or seismic seas waves, or shallow water waves. Why it is shallow water wave? See, when the tsunami is there, when in a deep sea, when the depth of the sea is very high, we won't notice the tsunami, because the entire wavelength of the tsunami will be within water. But because since the sea is deep, but as soon as the tsunami enters the shallow waters or continental shelf, the depth will decrease. Only the depth will be here. So what will happen? Tsunami will rise above the surface. Right? So shallow water, tsunami will rise. Right? So, what are the causes of tsunami? So there are two causes of tsunami within the waters. One is earthquake, subterranean or subterranean subhydrological earthquake, or volcano that happens. So volcano and earthquake are the two reasons. So when earthquake happens, the sea floor will be there, right? It will move abruptly. It will have a jerk. When jerk happens, the water over that region, it will displace. The water will rise up because of the earthquake within the waters. Water gets displaced. So then one big wave will come because of the displacement of water, and after that initial big vertical wave, there are multiple follow-up waves, right? After waves, it is called as after wave. So whenever even in earthquakes, what happens? First, there will be a big wave, but you should not feel happy that the big wave has come and we should not rest. There will be after effects. After wave will also come for 1 or 2, 3 hours. So we should be careful. Similar to that, tsunami will be also having after waves. One big wave, then later on we will have after waves, right? So what are the characters of tsunami? What is the character of tsunami? So the speed of the tsunami wave, it is actually slow in deep water. When the water is deep, or when the ocean is having lot of depth, the speed is slow. That is why in deep oceans the ship will be moving, right? They won't feel the tsunami. But as soon as they meet the shallow water, the speed will increase. Why the speed will increase? See, tsunami wavelength will be there. Wavelength of the tsunami, let's say it is okay. So this is the wavelength of the tsunami. So it is moving within water in the deep ocean. So as soon as they enter the continental shelf, what happens? The wavelength won't change. Wavelength won't change, right? But the speed also won't change. So when the period remains the same. What is the period? Period is from one point to other point on the wave. What is the time period? Time elapsed between two consecutive crests or two consecutive troughs. So that this is a crest. Between two crests or between two troughs, what is the time period? That is the period of the wave. So the period won't change, right? When the period won't change, wavelength also doesn't change. What happens? The height of the wave increases because, see, they enter the shallow waters. They will find obstruction. The ground will obstruct. When the ground will obstruct, the period won't change. So the height of the wave increases. The wavelength will get converted into height. So that is why you will find very high waves up to 15 meters, right? So in the deep, in the shallow waters, the wavelength reduces and height increases, whereas period remains the same. When the wavelength reduces, height will increase, period remains the same. So this is about the character of the tsunami. Why tsunami affects in the shallow waters, not in the deep waters. So where do you find the tsunami? So tsunamis are more found in the Pacific Ring of Fire. In the Pacific Ocean, you will find lot of tsunami happening, right? So what is the consequence of tsunami? Consequence is there is lot of destruction happens. Many people will die. Property will be damaged. So even the tsunami, just like earthquake, tsunami is also very difficult to prevent. You cannot prevent a tsunami, right? So with respect to prevention of tsunami or predicting the tsunami, we have one international organization called International Tsunami Warning System. International Tsunami Warning System is there. So we have one Indian organization also. Let me check. What is the Indian organization? This Indian National Center for Ocean Information Service, INCOIS in Hyderabad. So this also predicts the tsunami in India. INCOIS is the organization word. In the word it is International Tsunami Warning System, right? So this is all about the tsunami. Next we will talk about the cyclones, tropical cyclones. Yeah, so this is the cyclone map of India. So what is the, when we talk about the tropical cyclone, first understand why it is called a tropical. See, because it lies in the tropical area between 30° north and 30° south, it is called as tropical cyclone, right? So what are the characters of this cyclone? We have discussed about cyclone. In the middle of the cyclone, you have intense low pressure area. Low pressure area in the middle, around which there is, so there is in the middle you have a low pressure area. Around this the air will blow, the wind will be blowing, right? So the length of the width of the cyclone will be in thousands of from up to 250 to 400 kilometers. Width is from 250 to 400 kilometers. The height of the cyclone is up to 15 kilometers. It reaches up to tropopause, right? So where does this cyclone gets its energy from? Energy of the cyclone comes from the condensation of moisture. So these cyclones originate over the seas, right? So in the sea they will gather a lot of moisture from the ocean water, and this moisture, it is having lot of heat, but when they form into a cyclone, in the cyclone they will release the heat. So that heat is the energy from which from that heat the cyclone gets the energy. The heat from the moisture of the water content, that is where the cyclone gets its energy from, right? So there are many conditions for the cyclones to be formed. One is there should be a vast sea surface area. Sea surface area vast agirbeku, and the temperature should be more than 27 degrees Celsius. That is the first condition. Then there should be, second condition is supply of warm and moist air. So warm air should be warm and moist. ತೇವಾಂಶ ಇರಬೇಕು, ಬಿಸಿ ಇರಬೇಕು ಗಾಳಿ. So why it should be hot? Because that heat will only supply energy to the cyclone. That is the second condition. Third condition is there should be strong Coriolis force. Coriolis force I have discussed. I am not going to tell it again. That should be there, right? So why Coriolis force? If the Coriolis force is there, it will help in the rotation, right? This Coriolis force iddaga centrally low pressure iruttalla, that won't get filled, that will remain empty, right? So since why tropical cyclones won't originate in the equator, at the equator alli enu originate agala? Because there is no Coriolis force at the equator, right? This point is very, very, very important, right? Then there should be local disturbances. The fourth condition is local disturbance is atmospheric disturbance. Something is happening, pressure, volume, temperature changes, that will help. Then also there should be absence of vertical wind shear or vertical wind wedge. What do you mean by vertical wind wedge? Andre, the velocity of the wind at the upper atmosphere and lower atmosphere should be same. If there is difference, what happens? The wind will start flowing from top to bottom or bottom to top. So this is called as vertical wind shear. The velocity should be same, right? If there is if the wind wedge is not there, then if that velocity is same idre, the cyclones won't form. If the velocity is different, cyclone will start forming, right? There should be absence of vertical wind shear, right? So then we will talk about the structure of the cyclone. How is the structure? So you know that the center of the cyclone is called as I, where it is very low pressure, and around the cyclone there is large pressure. So if there is a cyclone like this, the pressure gradient will be high. Here you will be having low pressure, here high pressure. So the variation of pressure from one point to the other point is high. There is a large pressure gradient, right? So This is about the structure of the cyclone. We have discussed cyclone in detail in the World Physical Geography. So I'm just giving the gist. How is the cyclone distributed? In India, it is distributed in two areas. One is Arabian Sea, another is Bay of Bengal. So where do you find the cyclones most? Arabian Sea or Bay of Bengal? So Bay of Bengal, we will find the cyclones most. Most of the cyclones originate here, and even in Bay of Bengal, the cyclones originate mostly in the October and November time. So I see in the October, see in October and November, Bay of Bengal gets up to 53 and 56 cyclones per month. Arabian Sea also gets 17 and 21. Other months are having very less. June and July they get 34 and 38. So from this map you can make out that in the Bay of Bengal, starting from June or May, mid-May up to December is prone to cyclone. Whereas Arabian Sea, you see here, only June, July, October and November is prone to cyclone. So this is the data by the government agency. So hazard. So we'll talk about the hazard zone, cyclone hazard zones. What are the zones of cyclone impacting? So we have divided the cyclone hazard zone into 6 areas. Very high damage risk zone, very high. In very high damage risk zone, we have 2 areas, A and B, and then you have high damage risk zone, moderate damage risk zone. Even in moderate damage, you have 2 areas, A and B, and low damage risk zone. Totally 4 categories under 2 subtypes, right? 4 major categories, 2 subtypes. So this is a very high area damage, very high, and this is also very high damage, very high damage. And this is high damage area. This area is high damage to cyclones, right? And this area is moderate damage to cyclone. This interior Odisha is, interior Andhra Pradesh, Telangana is moderate damage, and this interior Madhya Pradesh and Maharashtra is also moderate damage. Karnataka plateau is again low damage area, right? So this is how the cyclone impacts, right? Impact hazard zones of the cyclones, right? Okay. So what are the consequences of the cyclone? So the consequence of cyclone is high in the coast or interior. Where do you find more consequences? You will find the consequences more on the coast. At the coast, you will have wind speed more than 180 km per hour. So there is one more concept of super cyclone. Super cyclone more than 250 km per hour, right? So that is the consequence of the cyclone, right? But the impact of the cyclone is less in the inland. That is within land, the interior lands, the impact of the cyclone is less. So cyclones, when we talk about the cyclone, we should speak about one concept called storm surge. What is storm surge? See, whenever you speak about storm surge, it is interaction of the land, sea and air. All the three things, land, sea and air combined together causes the storm surge in the ocean region. In the coastal areas you will find it, right? So how does a storm surge look like? See, this is how a storm surge looks like. Air, water and land, interaction of all these things. This is how a storm surge looks like. Clear? Did you see it? Okay. So even in because of cyclone, it causes the storm surge. Cyclone causes the storm surge, and there will be a lot of rainfall. Rainfall will be there. So next, this is about the cyclones in India. We will next move towards the floods happening in India. So what is the characteristics of the floods? How does flood happen? How is it different from other disasters? See, compared to other disasters, which are happens immediately, floods happen very slowly. They occur very slowly, and the good thing about flood is we can predict where it happens. It won't happen haphazardly, right, in pre-identified areas. And the one more good thing is we can predict when does it happen, expected time of the year the floods will happen. That is, let's say in the rainfall season, monsoon season, the floods will happen. So what are the causes of the flood? So when the carrying capacity of a river exceeds, see, one cause is supply side. If the glacier melt is high, there is lot of water in the rivers, then flood will increase. If the rainfall is high, floods will happen. That is one thing. The next cause is if the carrying capacity exceeds, that is, if the river channel is filled with debris, if it is having lot of deposits, waste deposits, mud, sand, silt, then also flood will happen, right? So these are the two causes. So these floods will happen also during storm surge. Storm surge, just as you know I showed, then also flood will happen. Silting, when there is high silting, floods will happen. When there is low permeability, andre when river channel iruttala, bed of the river, if it doesn't allow water to permeate to underground water, then also water will remain above it, and when water capacity increases, floods will happen. These are the causes of the floods, natural causes. Human causes, what is the cause of humans? Agriculture, too much agriculture will lead to floods. So we are encroaching floodplain area and growing crops there, that will lead to floods. Then deforestation, does it cause floods? Yes, it does cause floods, because deforestation leads to soil erosion. Where does the soil go and deposit? On the rivers, because of which flood will happen. Then colonization, that is, if there is a lake and the lake has dried, what will we do? We will go and build houses. We will colonize the lakes. So all this JP Nagar, all this Ebbal area, you will find lot of encroachment on lakes, right? So because of that, see, the best example is Chennai floods, 2016 or 17. Why? Because Chennai, what they did, all these rivers, river nalas, canals, wherever they found the dry land, they started building houses there illegally. So when the floods happen, they cry, right? So that is one thing, human intervention. So what are the institutions to protect the flood? We have Rashtriya Bar Ayog. Bara in Kannada it is drought, but Bar, B-A-R-H in Hindi is flood. Please don't confuse. Rashtriya Bar Ayog, right? This Rashtriya Bar Ayog says that in India 40 million hectares of land is prone to floods. 40 million hectares, right? So what are the areas of floods? Area liable to flood. See, the entire Ganga belt is prone to flood. Even the Sabarmati, Mahi river, wherever you have river, it is prone to flood. Thankfully, Karnataka again is not prone to flood. Even Brahmaputra is not prone to flood. See, Karnataka, that is the beauty of Karnataka. It is not prone to floods. It is not prone to earthquake. It is not prone to cyclones. Because it is located on the Karnataka plateau, right? So, but we have some drought areas, some other things we are having, right? Okay. And even in landslides also we are not prone to. Only in Western Ghats, some areas we will find the landslides. But floods, yeah, in North Karnataka there is floods. So every year we are finding that North Karnataka is getting flooded. Even Kodagu there was floods, right? So nowadays there is a change. Right? So these are the areas of floods. Now we have to mark this area also now. Even Kerala is prone to floods now. Kerala, right? Every year we have floods. So One more thing is, when it comes to flood, we have to know about the flash floods. So I told floods are happening, floods take place slowly, but flash floods happen quickly. Flash floods are very quick in occurrence. That is the flash floods. So Uttarakhand floods, it is due to cloud burst and flash floods. Floods will happen within no time, immediately, right? So what are the consequences of flood? What happens due to flood? There is inundation, entire agriculture. So villages will be submerged. Your houses will be submerged. Your crop, agriculture field will be submerged, infrastructure will be damaged, there will be, because of floods, see, when stagnant water gets accumulated, there will be lot of diseases, cholera, typhoid, jaundice, all these type of things. Then the only positive thing about flood is it brings good alluvial soil, which is helpful for growing crops. Fertile soil it will bring in, right? So how do we control the floods? We will build embankments. So if, let's say, see, this is the river. What we will do, we will put one embankment here, artificial embankment, so that water won't cross, right? This is the natural level above which we will put one embankment so that water won't cross. Then we will build dams so as to store the water. Then afforestation, increase the number of plants, that will also reduce the floods. Then remove encroachment. Wherever floodplain somebody has built a house, they should be thrown out from there, right? So this is the about the floods. Next, the opposite of flood, we will talk about the droughts in India. Droughts andre Bargala. Where is the drought map of India? Okay. Yeah, drought prone areas. Drought prone areas in India. See, what do you mean by drought? For an extended period, there is no rainfall, there is no shortage of water. That is what is meant by drought, as simple as that. So, when does the drought happen? When there is less rainfall, less precipitation and excess evaporation, right? Evaporation is high, precipitation is less. So, when does, and also due to overutilization of water, overutilization of surface and groundwater, that will also lead to drought. See, this, when we speak of drought, it is a complex phenomena. It includes rainfall, it includes groundwater, it includes surface water, it includes river water, lake water, it includes soil moisture, right? It includes moisture in the air, it includes precipitation, it includes rainfall, evaporation. So it is a very complex concept, very interconnected concept, right? So what are the types of drought? These types of droughts are very, very important. They are going to ask you directly in the exam. The first type of drought is meteorological drought. What is meteorological drought? See, when there is inadequate rainfall, rainfall agila andre, or rainfall is distributed unequally over the places, unequal distribution, or there is no rainfall, then it is called as meteorological drought. Then the next type of drought is agricultural drought. What is agricultural drought? Soil moisture. If the moisture in the soil is less, it is called as agricultural drought. Very important concept. But some areas, they straight away declare it is not prone to agricultural drought. So what are the areas? If 30% of the area is irrigated by canal water or river water, then it is not prone to agricultural drought. 30% criteria. That is the second type of drought. The third type of drought is hydrological drought. What is hydrological drought? So in the storages, that is reservoirs and dams, if the water level falls, that is hydrological drought. Then you have one more type of drought called as ecological drought. What is ecological drought? The productivity of the ecosystem, that is ecosystem biodiversity. the production of various products. If the productivity drops, it is called as ecological drought. Clear? So these are the types of drought. So what are the areas prone to drought? So we have 4 types of area: extreme drought prone area, severe drought prone area, moderate drought prone area, and drought free area. See, the Rajasthan Gujarat belt is extreme drought prone area, and the zone 2, that is Madhya Pradesh region, and also some part of Karnataka, Andhra Pradesh, Tamil Nadu is severe drought prone, and other area, yes, the most part of Gujarat and Maharashtra and the northwest part of Karnataka is moderate drought prone. Even the some parts of Rajasthan and lower belt of UP is moderate drought prone, and the most area of the Chhattisgarh, Odisha, and some part of Telangana, Andhra Pradesh, the entire Ganga plain, the entire Brahmaputra plain, the entire Western Ghats, southwest Karnataka, and also Kerala, some part of Tamil Nadu is drought free. You should know where are the droughts happening, right? So we say that 30% of area in India, 30% of area is declared to be drought prone. How much area? 30%, right? So there are some areas, there is one peculiarity. See, the peculiarity of India is, let's say Ganga is facing drought. Rajasthan at the same time will be, Ganga region is facing floods. Rajasthan will be facing drought. Same country, flood and drought occurs simultaneously. And there are other, let's say in Karnataka, northern Karnataka, in summer it will be drought, right? In rainy season it will be floods. Same area, peculiarity. This is the peculiarity of India. So, and floods also, this drought, why more drought in India? Because we are excessively dependent on monsoon rainfall, right? So there are 4 types of areas. So extreme drought prone, I have discussed all these areas. So what are the consequences of drought? So consequences of drought, very, very important. It is if there will be food grain shortages, so we won't have sufficient food to eat. So what is when the food, when we don't have food to eat, what is it called? Akal. No food means akal. And then fodder, for animals don't have food to eat, it is called as trinkal, Trinkal, trinkal. Then we don't have water to drink, it is called as jalkal. All these 3 things combined, akal, trinkal, jankal, totally called as trikal. Trikala barantarala, that is the concept, right? So it has an impact on cattle. Cattle will die. Humans, what will humans do? Human will also die, but most of them, they migrate to other areas. But cattle, poor fellows, they don't know where to migrate. They will die, unfortunately. So during drought, what happens? Humans are forced to drink contaminated water, because of which there will be lot of diseases. So how to prevent the drought? We have to do drought planning. We have to plan for the drought. There should be proper planning. So what are the steps? So groundwater, we have to increase the groundwater potential. Groundwater should not be exploited indiscriminately. See, these agricultural fields, farmers, what they do, because electricity they are getting subsidy. There is free water from the groundwater, right? Also on the pump set they are getting subsidy. They will misuse the water like anything. Do you know that up to 80% of fresh water in India is consumed by agriculture? Only 20% is used by humans, 80%. So agriculture, they should not misuse the groundwater. That is one thing. Then we can build dams and reservoirs to prevent the drought. Then we can carry out river interlinking. What do you mean by river interlinking? See, Ganga, always it is having water. But let's say Mahanadi, it is not having water throughout the year. What we can do is, we can interlink Ganga and Mahanadi. So excess water from Ganga will flow into Mahanadi. So there is a national. So we are linking these two rivers. Ken Betwa River in Madhya Pradesh and Uttar Pradesh region. We are linking this Ken Betwa River so as to prevent the drought. Right? Excess water from Betwa flows into Ken. Right? So this is the first interlinking project we are doing. And also in order to prevent the drought, we can increase the knowledge among the farmers. See what knowledge? See, even though there is no water, our farmers are so adamant, they want to grow rice only. They want to grow sugarcane only. So these are water guzzling crops, means they want lot of water. So instead what we can do, we can put drought resistant crops, jowar, jola, ragi. So they don't require lot of cotton, they don't require lot of water. So drought resistant crops can be planted, right? This is all about the drought. Next we will move to the landslides. Landslides in India. So what is the meaning of landslide? So rapid sliding of a large land mass. So you know what is a landslide. So when large landmass comes down suddenly, it is a landslide. So the peculiar factor about land, see, if you take the cyclone, if you take the tsunami, if you take the earthquake, it is having global connection. But landslide is local. If the local area, only that specific mountain, that specific hill, it is confined to, right? So it is a localized factor. It is always dependent on localized factor. So because it is dependent on localized factor, it is very difficult to predict it. It is very difficult to monitor it. How can these people, disaster management people, go and find out every landslide? It may happen anywhere, right? So it is very difficult to predict and monitor. So, but what we can do is, so based on past experiences, in the past where all landslides have happened, wherever the soil is loose, those areas we can carry out a survey and prepare a landslide map zoning. We can prepare a landslide map. So based on that, they have prepared a landslide zoning map. So the first area is a very high vulnerable zone, very high landslide vulnerable zone. So which are the very high vulnerable zone? Landslide, Himalaya tectonic, because mountains are crushing, landslide will happen, right? That is the first area. Andaman and Nicobar is the second area. Western Ghats is having high landslide potential. So that is very high. Then is high vulnerable zone. High vulnerable zone is similar to very high vulnerable zone, but the landslide frequency is less compared to same areas, Western Ghats, Andaman and Nicobar and Himalayas only. But it is having less frequency in intensity. Then you have moderate to low vulnerable area. So what is moderate to low? The Ladakh region, Trans-Himalayan region, that is low. Then you have low precipitation area. Wherever there is less rainfall, there is less landslide. Why? See, when rainfall happens, it loosens the soil. So landslide will happen. Then not only that, rain shadow area. Where is rain shadow area? The Western Ghat rain shadow area, leeward side, that is also moderate prone to landslide. And mining areas are also prone to landslide. So what is the consequence? So because of landslide, the roads will get blocked, right? It is transportation will be affected and houses will get buried, people will die, and also river. See, if there is a river and there is a mountain here, land slides and fills this river will be forced to go somewhere else. River water will be diverted, right? So how do we mitigate? How do we stop this? We have to have area specific measures. Specific area again, we have to have specific measures. So what we can do is, if the area is prone to landslide, what we can do is, if we can build one embankment here, one wall like here. See, I was watching this National Geography. on the other day, and I found this very interesting example. In the Canada region, they have a lot of avalanche. What is avalanche? It is just like a landslide, but instead of mud, there will be ice. Avalanche is a snow or ice coming down. So what they do is, they do carry out, so they know where the avalanche or the ice flow happens. So what they do is, they have a map of those areas where it is prone. So they will be keep monitoring those areas via helicopter, right? They will be traveling and doing this surveys. So whenever there is excess ice accumulation in the area, what they will do is, they will see, when the landslide happens on its own, it might cause damage. But what if we cause the landslide deliberately? What they do is, they will throw bombs in the area. So they will throw some 2 or 3 bombs and explode. When the bombs explode, automatically landslide will happen. In those areas, in those times when the bomb is exploding, they will block the traffic. They will evacuate the people. So all the ice will come down. The area will not have any ice for the landslide. See, any landslide had to happen. So we ourselves, we will cause the landslide. So all the ice is removed and the road will be later on cleared, right? This is one type of example I found in Canada, but I don't know how they will implement it in India. If they blast a bomb, people will cry. Okay. So in India, it's difficult to implement those kind of extreme measures, right? So what are the mitigation measures? We have to have area specific measures. We have to restrict construction in landslide area prone areas. Construction should be restricted. There should be no human settlement, and there should be no agriculture in those areas. Those areas, agriculture should not be there. What can be done? We can do afforestation and terrace farming can be done, right? This is with respect to landslides. So next we will talk about so how do we manage? So we have spoken about all the disasters. How do we manage the disaster? So see, when it comes to disaster, except cyclone, all the other disasters, it is very difficult to predict, right? So only cyclone we can predict and manage. How do we predict? How do we manage? By the cyclone shelter, cyclone embankments, all these things. So with respect to cyclone, disaster management, we have National Institute of Disaster Management that is there. Then we have National Disaster Management Authority, State Disaster Management Authority, District Disaster Management Authority. Who is the head of District Disaster Management Authority? It is a DC, District Collector, right? So we have a Disaster Management Bill, Disaster Management Act 2005. It defines disaster. So what does this act defines disaster as? Disaster is defined as a catastrophe, mishap or a calamity which is either natural or man-made. Catastrophe, mishap, calamity, Allah one day. It is a disaster which is either natural or man-made, or which is either accidental or due to negligence, which happens due to either accident or a negligence, which causes loss of life and property, loss of life and property, and which is beyond the coping capacity. And humans cannot cope with it. It is beyond the. So this is what the definition of the disaster as per the Disaster Management Act. Not very important, right? So next we will talk about the overall mitigation and preparation, overall mitigation, reduction of the impact of the disaster. So we have to be prepared for a disaster. That is the first step. Then we can have data and information of the vulnerable zones. Whichever zone is vulnerable for disaster, we have to have data about it, and we have to have maps of the disaster, and we have to increase the awareness of the people. We have to plan to prevent the disasters, right? And this is before disaster. But during disaster, we have what we have to do? We have to rescue the people. We have to provide them food, water. We have to provide them shelter. We have to give them some money also. So they rebuild their life. right? Then post-disaster, once the disaster happens, we have to focus on rehabilitation and recovery. So this entire thing, this is the entire India physical geography. So we have completed the second major chunk of geography, India physical geography, right? Now we will be moving towards India human geography. Compared to physical geography, human geography is very, very simple. So, India human geography, the first chapter under your India human geography is population. This is the only thing which we have done properly. Population. So, population, the first chapter is distribution of population, density, growth and composition of population. So, coming to population, what is our record? We are the second most populous country in the world, right? But if they carry out another census now, we have beaten China. We have already the most populous. But since census has not happened from past 11 years, there is no data. So last census we said that India is 1.21 billion people. Andre 121 koti. But now we have crossed 135 crores easily. So now we have beaten China already. Right? So we are the most populous unofficially. So we have to wait for the census data for the official confirmation. See, whenever there is an increase in population, what happens? See, our resources are limited. See, India is having just 2.4% of the land, world's land. It's the 7th largest country, but having just 2.4% of the land, having the highest population. So we will be facing difficulty with respect to natural resources, food, water, housing, all the resources, government services, everywhere there will be strain on resources. So this is with respect to population. So who measures the population? It is measured by census carried out every 10 years. The census is carried out. The last census was in 2011. The census should have happened by now. Because of COVID, it has been postponed. So 2011 census is the first digital census. Right? Before that, it was a manual census. So when was the first census happened in India? 1881 is the first full-fledged census. But the first census happened in 1872. Population census. There are various types of census here. There is agriculture census, tiger census, so many things. So we are talking about population census. Population census first happened in 1872. But first full-fledged census, the entire country, happened in 1881 thanks to British. British have done a lot of good things, equally bad things, right? So distribution of population. So distribution of population, it is very uneven. In India, population is distributed very unevenly. See, Jammu and Kashmir, there is less population. Arunachal Pradesh, there is less population. But see, entire Ganga belt is having so much population. Even this region is having high population. Kerala is having high population. Karnataka, Tamil Nadu, less population. Comparatively less. And Madhya Pradesh, here you have. So this Bihar, UP, West Bengal, this region, the entire Ganga belt, Haryana, it is having too much population, right? So this is the distribution of population. It is uneven, right? It is not equally distributed. So it is very uneven. Some areas very less population, some area very high population. Which state has the highest population in India? Uttar Pradesh. Which is the largest state in India? Rajasthan. Highest population, it is Uttar Pradesh. So what are the factors based on which population is distributed? So first is a physical factor, physiological factors. Wherever there is good climate, people will go and settle there. Climate is, that is why Bangalore, a lot of people are coming and settling here, right? Okay. Climate, then terrain. So people don't prefer to settle on mountains. They prefer plain areas and they also prefer coastal areas. Right? Plain and coastal areas, and also people prefer to settle where there is water availability. Right? That is why Ganga region, there is Because water is there, agriculture can be done. So lot of people are located there, right? So then other factors is where there is good transportation facility, where there is good energy and mineral facility, minerals are available there, people will go and settle, right? So this is the physiological factors. Next we will talk about the socio-economic factors. Socio andre physiological andre with respect to environment. Socio-economic means samajika ಮತ್ತೆ ಆರ್ಥಿಕವಾಗಿರ್ತಕ್ಕಂಥ and historical factors. ಐತಿಹಾಸಿಕ ಚಾರಿತ್ರಿಕ ಅಂಶಗಳೇನು for population settlement. See, settled agriculture, wherever agriculture is there, their population is high. Wherever transport facility is there and wherever industry is there, wherever the urban areas are there, rivers are there, right? These areas you will find lot of population. Industry, transport, agriculture, urban areas. So all these areas you will find lot of population, right? So next, this is the distribution of population. Next we will talk about the density of population. For when we speak of density, so the first we should speak about is the definition of density. What is the definition? Number of people per unit area. See, the density of this classroom is, if the classroom is full, density is high. If the classroom is low, of Kali, density is low. So the number of people per unit area is the density, right? So India, the average density of India is 382 people per square kilometer. Per square kilometer ali andre 1 kilometer length, 1 kilometer breadth. So in this area there are 382 people. That is the average density. So but this density earlier in 1951 post independence it was just 117. Now we have increased 3.5 times, right? The density has increased 3.5 times, but this density is also not equally distributed. See, density, Arunachal Pradesh, if you take, there are just 17 people per square kilometer, very sparse population. But if you take Delhi, National Capital Territory of Delhi, the density is very high. Per square kilometer, how many people are there? There are 11,000 people in 1 square kilometer in Delhi. Whereas Arunachal Pradesh, just 17 people, right? So, which is the most dense state in India? It is actually Bihar. They have changed it. It is, so as per the recent data, it is Bihar is the highest densely populated state. I will also check it once again. It is Bihar. I have seen the recent data. Okay, they are saying it is. So this is with respect to census data, but recent data it is actually Bihar. See, Bihar is the most densely populated state. I've checked the recent data. So see, some data is, we cannot rely on Google. See, we will talk about the, I'll find it is actually Bihar. I have seen the recent data. So as per, okay, so as per the 2011 census, it is Bihar, right? Bihar is a highly popular, highly dense state, but what is the recent 2021? So they are saying it is Bihar. Yeah, it is Bihar only. This is okay. This is with respect to 2011 data. What is the recent data? I'm not able to. So this is with respect to 2011 data. 2011 data, it is Bihar. I saw the recent data. It is Okay, 1 second. It is definitely not West Bengal. See, West Bengal is having just 905. Bihar is having 1102. So I think we should stick to Bihar. We should stick to Bihar. Bihar is the densely populated state as of now. See, it is having 1102 people, right? So it is Bihar. Bihar has a total density of 1106. So one more data. So we use stick to 2011 data. It is Bihar, right? Okay. Because these types of data they will ask in the lower level exams, state level exams. Okay. So West Bengal is the second dense. It is 1029 people. UP is having 828 people. So there are two types of density. When we speak of density, it is there are, see, density andrenu, it is the relationship of land and humans. How many humans are there in a particular area of land? So this density is divided into two things, two types. It is either physiological density or agricultural density. What is physiological density? So the total population per net cultivated area. What do you mean by net cultivated area? What is gross? What is net? At present, if you gross cultivated area and overall cultivated area, but net cultivated area at present, what is the area that is cultivated? Andre elli crops na grow madidare, that is net cultivated area. The total population divided by net cultivated area is the physiological density. Then is the concept of agricultural density. Agricultural density is total agricultural population. Total agricultural population by net cultivated area. What is agricultural population? See, agricultural population andre there are two people. One is the cultivators who own the land, and the second thing is agricultural laborers who don't own the land, they come and do the work. This is the agricultural population, that is agricultural density and physiological density, right? So we will talk about the next is the, this is about the density of population. Next we will move towards the growth of population. So there are two types of growth. One is the natural growth, another is induced growth. What is natural growth? See, whenever we have to speak about the growth of population, we have to monitor birth rate and death rate, right? How many people are being born, how many people are dying, right? So natural growth andre, if the difference between the total number of people being born and the total number of people dying in a particular year, this is the crude rate. Crude andre, we are not measuring the rate, but total number of people. So crude birth minus crude death, that is total number of people born, total number of people dying in a particular year is the natural birth rate. But next is induced growth. Induced growth. What is induced growth? Induced growth andre, see, in a particular area, whoever are born, whoever are dying, it is natural rate. But that area, if other people are migrating inside, some people are migrating outside, it is induced rate, right? It is because of migration. So the annual growth of India's population is how much? It is 1.64%. We are growing at a rate of 1.64%. Andre, what is 1 point andre? If 1000 people are born this year, next year it is 1064 people, right? 1064, sorry, not 1064, 1.6, right? So it is 1016 people. 1016 people are born next year, 16 people increasing next year, right? But this is with respect to 1000. You take crores, 100 crores, then it will be a huge number. 1.6 is a huge number, right? So this is annual growth rate is to 1.64%. Next we have one more concept called decadal growth rate. What is decadal? Decade means how much? 10 years. So between 2001 to 2011, the population in 2011, let's say it is P2. Population in 2001, it is P1. So P2 minus P1 divided by P1 into 100 is the decadal growth rate, the formula for decadal growth rate. Then you have one more concept called population doubling time. What is population doubling time? The amount of the time period in which the population doubles. Let's say today we are 50 crore. By how much time we will become 100 crore? That is double. That is the population doubling time. So this is all about the population growth with respect to specifically. See, whenever we speak of population growth, you should know about the Thomas Malthus theory of demographic transition or the demographic transition theory. We will speak about that tomorrow. Also look at the phases of India's population. So any doubts, anything you want to, any feedback on the classes, please put it in the comment section or reach us on our Telegram channel, VHS Education Forum. I thank you all for attending the classes. Please make good use of the classes and also take care of your health. We will meet tomorrow. Jai Hind. Namaste.